is what is it that we're talking about? What is injection molding? You've probably heard this term. You've maybe used it a lot. Most companies use it to produce their production parts that are on their for sale units. So injection molding is basically just injecting molten plastic into a permanent aluminum or steel tool to make custom molded plastic parts. So I kind of think of it as like waffle and waffle iron. You know, we make both. We build tools and we mold parts, or waffles and waffle iron. So the ways that it can help you. Why might you use this? And it is a tool that will allow you to quickly validate your part design and production capability in the correct material. So when we look at helping you with injection molding, we are looking at this from the standpoint of going from early on NPI, product development, prove out your design, make sure things are right, possibly before you go to high volume production. You may use aluminum tools as NPI tools, as bridge tools, as early run, get some parts, but you really need them to be in the correct molded material. 3D printing and machining and the other technologies that I talked about earlier can provide you excellent parts that work very well. The technologies are improving. 3D printing, for example, is constantly getting new and better materials, and we have more that we're introducing in the marketplace. But often it's still not the particular glass content that you need or the particular color that you want. It's not the actual the actual resin. It is still somewhat of a compromise. So injection molding sometimes is the only way to be able to mold parts, to be able to say apply to a medical application, or you're going to be exposing them to UV or certain chemicals, and you must know how they perform. Injection molding is the way to do that, and we want to help you make those things fast.
It really takes it to the next step in your testing process. Like you said, Jesse, if it needs to go to UV, where you're going to run the actual material and it's going to come out of what's very similar to your production mold and go to that next level. That's
right. But often you need it fast. So you just need to know, somebody that can take care of it for you quickly, and we're a great resource for that. Then achieving customization and detail and geometry. Oops, can we roll back to the previous slide? Thank you. So sometimes you need customization of your geometries. You need to know exactly how the thing is going to look, exactly how it's going to perform. Customization might mean, you're trying to dial in on a tolerance on a feature that allows you to slide in a little sheet metal part, for example, that will work correctly in your assembly if it's molded correctly and has the right tolerance and so on. So there's some customizations, some tweaking that you might not be able to hold with 3D printing or machining or other technologies, and injection molding can help you achieve your actual design. Development. This is an important point that we want to make is you may use injection molding to produce those early development parts and prove it out, make sure it works well, and then you want to then step into either bridge or full production. And our tools and the process that we're talking about with you today are absolutely capable of that full spectrum. You may find, wow, these early parts that I thought of were from an early development tool actually work excellently. The tolerance is great. The cosmetics are good. They're fully textured. They look excellent. Why not use this for production? And we are here to say you can. These are tools that are capable of producing parts in production. So consider it that way. And that means that there's more added value, and also it can help reduce lead time because you were producing a tool early. You meant it for early development, and you realize, wow, I can use this to produce thousands of parts very quickly and inexpensively. Increased throughput from low, medium, kind of along the line here. These tools these are fully capable. We have the ability to design tools that have everything from hand load inserts for undercut features to fully automated and fully engineered slides, lifters, cams. The investment that we make, that we work with you on how we engineer and produce the tool, can have a big impact on the cycle time or the throughput of the tool, and also multiple cavities that we could do, single cavity to multi cavities. And however we make that tool will affect how quickly we can manufacture parts for you. And we can make, we run multiple shifts. We can make you thousands of parts a week to get you up and running very quickly and into production. So then moving on, we say increase throughput. So we say a couple dozen to 100,000 plus parts a year is our typical range of what we're looking for capability and for projects as a match. Reduce cost per part with our aluminum molds in single or multi-cavity configurations. I just talked through that just a little bit. We'll go through aluminum and how it helps reduce costs in some of the later slides. But we've got, if you do a little bit of investment in tools, like I said, with slides, lifters, multiple cavities, you can help reduce part costs substantially. And we do that very, very often. All right, cool. Any questions? Remember to type those in the chat before we move on. If not, then we'll hop into this next slide. So this next slide kind of gives some definition of our meaning of these different types of tools. We have rapid injection tooling, what's kind of called bridge tooling, and production tooling. And the point of this slide is to kind of show that there's a blurry line between them, and you may use what was considered a rapid injection tool on the left for your production tooling on the right. But there are some differences to consider, and just so that we kind of set the tone on what the terms are. So rapid injection tooling is typically 2 to 5 week lead time. But then that range depends really on the complexity of your part, the size of your part, how many cavities we're making in the tool, what kind of, we say materials, what kind of mold base we're making for you. Some of those kinds of features or variables can affect that lead time to give that pretty substantial range there. But we are focused on speed, and we're focused on parts that can be quite complex. So in the rapid injection tool, we're going to be using aluminum typically. We're going to be on the rapid side, we may say use hand-loaded inserts for undercuts versus fully engineered. We may make a single cavity instead of multiple cavity. We may use simple gates instead of, say, a hot drop into the tool. We may use EDM to create texture instead of sending it out to Moldtech and having the Moldtech 11030 or what have you applied to it. There are some areas that we can slightly tweak to make it a faster, less expensive tool and more on the rapid side. Bridge tooling, stepping over into the middle, lead times are similar, 2 to maybe 6 weeks on the outside for a real complex part. And some of the differences might be that we go into automatic ejection. We may go into automatic operation of the slides and lifters. We may make multiple cavities. We could add more complex heating and cooling systems with water and oil. So there just might be a little bit more details. We start to also then enter into the steels. And of course, Hokotol, we're going to go into plating and so on. We may plate a tool to give it a longer lead time, some other features that we could add to make this more capable of higher volume. And then into production, then that is also going to be potentially be the aluminum tooling. But by here, we definitely are plating the tool. We definitely are automating. We're usually multiple cavity. We may have some more things like subgates and things that help reduce cost as we're molding parts, reduce our need for human overseeing the molding process. So it's a little more automated. We can take care of you for this entire process, and we can go through the options with you early on. Okay, next slide.
So what to expect from rapid injection tools? When we say accelerated design and validation, like I kind of when I introduced myself, we're here to talk over your part design, part concerns, and we're real time where if you send over questions and concerns or pictures, we can review that. We can have one-on-one Teams meetings to talk through your part to get to a good moldable part moving forward. So that's one thing we definitely offer. The cost efficiency with aluminum tooling, Jesse kind of hit on it a little bit as well. When we're talking cooling and things like that with aluminum tooling, we can actually run aluminum tooling a little bit faster because of the thermal conductivity of aluminum versus steel. So that is where the cost efficiency with aluminum comes into play with our tooling. The flexibility in material selection, we can run several different materials in aluminum tooling, all the way up to 50% glass-filled nylons. Now, when we get into the glass-filled nylons and that glass content, we definitely want to educate you to go to hard coating the tool to protect not only the tool but to protect the detail and the quality of parts that you as the end customer receive. The enhanced precision and consistency. When we talk about this, there's really, as far as the tolerances in aluminum and in steel, there's no differences. We're going to have the exact same tolerances in aluminum that you would get in a steel tool. So contrary to what you may hear out there, the tolerances, we will hit exactly what you can hit in steel. The production quality built into prototype lead times. This is where we kind of say we try to produce exactly what you're going to get out of a production tool, right out of our aluminum prototype tool. We don't want to cut corners. We don't cut corners with customers as far as removing undercuts. There's really no limitation with us. Lifters, cams, we provide all of that. If there is a major issue, we obviously talk through it with you as a customer and show you our concerns. But we want to provide a production quality prototype part to you out of every tool. Plating with NIBOR, increasing from 5,000 to 50 to 100,000 pieces. Now, NIBOR is something that we highly recommend if you are going to run any more over 5,000 pieces off your tool. We highly recommend that you hard coat it sooner than later. This not only protects the tool, but it gives it a lubricity on surfaces like if you are in if you have a very long or deep rib in a plastic part, and you can only allow very, very limited draft on a rib. That's where NIBOR really comes in handy, and it gives it that lubricity to help eject the part out without damage to the part. So we've been using NIBOR for years and had very, very high success. As far as talking glass-filled material, we have several tools here that we run 40, 50,000 pieces a year on 33% glass-filled nylon. So, it just goes to show that the NIBOR, for the very low cost that it is, it's very much worth it when talking aluminum tooling.
So Justin, there's a quick question that came in. What is different for aluminum tools versus normal production for steel tools? And so Justin's we'll address that when we go through a few slides later. We talk about the actual aluminum we use and how it's a little different. There's actually that question kind of seems to be like, what's the negative? What are the compromises that need to be made? And actually, there's some advantages. So we'll talk through kind of both so that you understand it. But the differences technically aren't that big when you talk about the molding of the parts between aluminum and steel. Except for some of the thermal conductivity. So if anything, it's just better in aluminum. Then with the hard coating, which to be clear is something that we provide as a service. So it's something that's elective. You don't have to do it. We certainly don't do it when we produce the tools and mold first articles. Then we go through, once the tool is correct and the parts are coming out good and you're ready to go, then we take it and hard coat it. And that adds a whole bunch of extra life to the tool, lubricity and mold life, as Justin mentioned. It also kind of helps enhance some of the surfaces. It helps protect if you've got a polished surface and so on. So that coating can help level the playing field a bit between aluminum and steel. So just because it makes the tool harder and allows us to run more parts through it. So it really makes them quite similar to aluminum or to steel. So you get the advantages of both.
Yeah, absolutely. Just to give you a quick idea, as far as the surface hardness, when we do hard coat an aluminum tool, the surface hardness is 5052 Rockwell. So it kind of gives you an idea of how and why we're able to run, a very high glass filled content material and still run, 40 to 50,000 parts a year on our tooling. And then moving on to the last bullet point there, as far as we do accommodate design changes. Once we've provided first articles off an aluminum tool, contrary again to what you hear out in the world, that once we mold a part and you're stuck with that tooling, you can't do changes to aluminum tooling. That's 100% not true. We offer, we quote and do revisions day in and day out. So if you have a part change, you send an updated 3D model over to us, we review it, and we will quote changes for you, whether that will be inserting the tool, or we can also laser weld aluminum. So we're very diversified, and we offer a lot of benefit there for changes, because obviously we know that in prototype tooling, you get your parts and you find that there's areas of the part you need to change. So we're here to accommodate that as well.
Justin, that's a really, really good, important point. Thank you for making it. And this actually goes right into a question that Heather just sent into us, saying, I create 3D parts, but need help transitioning the design to be injection moldables. Is that a service you offer? And the answer is yes, both in helping with consultation for how to design your parts for injection molding. We do, of course, the 3D printing on the front end and can help you print parts, and then start to analyze. As we're doing that, we can start to analyze and look at your parts for injection molding. So if you get us involved early and often, then we can help you with that transition so that you end up with a better injection molded part. And then to what Justin was speaking about with modifiable tools, you may not know exactly how you want a feature to work, or you may not know exactly how, say, clips are going to fit between a front and back housing and how tight it's going to be so that it can fit your or pass your drop test and so on. And we can help you with making the tools metal safe so that we can creep in on dimensions. We can also make modifications to the tool if you decide that you need to, say, change a rib or where a feature is on your part, maybe make it a little thicker if it failed drop test or what have you. We're very able to make changes. You do not have to make a new injection tool unless it's economically better, because there's such big changes that it just makes sense to remake certain components of the tool. But this is something that's very modifiable. And we work with you very closely to help make sure that that's all done smoothly and as fast and as inexpensively as possible. So being adaptable helps you, not be as locked into something that you can't use if you need to make changes. So that's really, really important. This material is very modifiable, and our team is very expert at dealing with that. We have some bullet points here on some kind of, say, differentiators or things that you may have experienced in the past that are limitations, or maybe even currently to limitations to what your current injection molding process is. So we just kind of wanted to go through those so that you know kind of what to expect from us and what sorts of alleviation we may have for some of your pain points. So we just talked about transitioning from 3D into injection molding, or even just dialing in your injection molded part. You're not sure about draft. You're not sure about radii in a corner. You're not sure about thickness of ribs and if you're going to see sink marks and that sort of thing. Getting rapid feedback on your part design, or design for manufacturability, that's what DFM stands for, with, say, where we're going to put the parting line, where we're going to put the gates, which is where the ejection happens, where plastic flows into the mold. And then ejection is where the parts, they're little aluminum rods that push the tools out. Sometimes they're blades, and there's lots of different ways to do it, where we're going to put those features so that we make sure that they don't interfere with the cosmetics of your part or with the function of your part. Having an interactive discussion about how we're going to do that is really important, and that DFM will help us all succeed. We want to make you good parts, and having some good, quick analysis of your parts will help us make you good injection tools. So DFM is critical. That's for both the tool components and then your parts. So those first 2 points are on the tool and then the parts themselves, including mold flow, which is an available service. We can do a light mold flow included in your quote, more significant mold flow if you're, say, going to be looking at a more complex part design, maybe multiple gates in a part. Some other cases where having a more complex and thorough mold flow is a little bit more important. We use Moldex 3D as a mold flow tool, so we can present that to you, feed it back to you so that you can have that for your project files. We have 3 and 5 axis. It's really important to understand 5-axis CNC is very important because that allows us, 5-axis allows 2 more axes that allow us to get into complex shapes on your tool, so that we're not limited to having, say, complex curvature on your part. We're not just going to be 3-axis CNC. We also have EDM, we have sinker EDM, which allows us to, again, to make complex curved shapes, deep ribs, sharp corners, some things that if you get into the details of that with some manufacturers, they're going to push back and say, well, we can't make that thin rib that deep, or we're not going to be able to make that sharp corner. We're not going to be able to have that slider lifter that's going to allow you to make that undercut. So you have to change your design. So our purpose is to try to make you able to make the design that you want to have manufactured. So we have the tools to do so. Surface grinding is just important to know, to dial in on some features, some tolerances, certainly some features in tools that really need to be ground, can't be CNC. That also can be a big effect for removing weld and creating nice transitions as we modify tools as well. So very importantly is the next one, slides, lifters, and cams to form undercuts. So undercuts on an injection mold are any feature that can't be removed from the mold in the direction of pull. So you have the core and cavity separating. If you have a hole, if you have a lip, if you have an O-ring, seal groove, those sorts of things that aren't in the direction of pull, you may need to use slides, cams, or lifters to release the tool or the part from the tool as it opens. We have that capability. We do that on a lot of our tools. We're not going to limit you to what you can design into your part, other than, of course, physics for injection molding. But we have the capability here and can consult with you on where those features are going to be so that you understand the impact on the outcome of the parts. Sometimes they can leave witness lines. They sometimes need to be operated in such a way that you may need to, say, modify your design a little bit to allow room for those things like lifters to operate, or cams. So we can consult with you through that. Contoured ejector pins is a funny little detail that actually comes up to be very important sometimes. And all that means, ejector pins are round ejector pins or blades. And I mentioned some other ways that we can eject, but they're straight. And sometimes, to save cost and money, companies only have the ability to install straight ejector pins into a tool. So that means when you have a curved surface, you're going to have a straight, flat ejector pin, and it's going to leave a big mark and not follow that contour. We can grind them, we can EDM them or CNC them to be the same contour as your part. So you're going to get good functionality. If you've got something sliding over your plastic part, you're going to be able to expect to have an ejector pin that's going to perform well, or ejector pin marks that are left. So that's very important. Then polishing to SPI A1, which is that's the highest level of finish. That's making clear lenses, light pipes, windows, features that are needing to be highly polished so that you can eject them from the tool correctly. That allows us to possibly sometimes get some parts with very low draft, which often you're looking for bores and things that need to not have a lot of draft. So having good polish, the ability to do this is very important. We show a slide later on that. And then also texturing to industry standards. So that means Moltec, those kinds of textures. If you have leatherettes, or you're doing an automotive texture, a stipple texture, Tennebec type texture, we can do those as well. We do that both in-house with EDM and out-of-house with Moltec and Tennebec textures. And then on-site part molding, both single shot and over molding. So we make the tools and we mold the parts in our same facility in Centerville, Michigan. So we have the ability to quickly manufacture your tool, test the sample parts for first articles. If there are any kinds of issues or dialing it in, we can send that back to the tool room quickly, make those tweaks, and get them back in the press to mold so that we can go through first articles, any modifications in very quickly. And then a full tool and or part inspection. So if you want to know the dimensions on the tool to make sure shrink rate is right, and any kinds of features that you're looking to dial in, we can actually measure the tool, and then also, of course, the part. And we will provide inspection reports. We do simple inspection reports in-house. We also work with a outside metrology company if you want to do CPK studies or any of the PPAP up to level 3. We do that externally so that you have an independent metrology source. Okay, if there aren't any questions, then let's move on to the next slide. And this one is I think, Justin, were you going to speak on this one?
I think both of us were going to kind of walk through it.
Yep, great.
Yeah.
So how to attain high quality and fast turnaround? First thing is get us involved early and often. As I mentioned earlier, getting us involved in the prototype stage is very helpful. That allows us to get some eyes on this, work with Justin and our tool designers to start to really give you good feedback. So having that early is great. That will help us with designs that are, say, uniform wall thickness and optimized geometries. So you may not know exactly how thick to make those ribs so that you don't get sink. You may not know yet if we can make a feature, if there's enough room to operate a slider, lifter, that sort of thing. We will consult with you early and often to help get through that so that your geometries are optimized, so that we help make you fast tools with very high quality and low cost. Prioritize materials for quick turn processes. So that is, prioritizing aluminum where that makes sense. Maybe looking at the right molded materials, which we'll talk through the available materials that may come up there. So we can kind of work through like, hey, you're intending to use one kind of material. We can't get it quickly enough, or you can't get it from your production supplier. We may have some alternatives that we can kind of work through very quickly. So that is something, part material is a really important part of the whole analysis of how to get you speed and quality. And then that DFM analysis that we talked about, doing that up front, doing that early is very important. We'll help you through that. And that goes into the next bullet of rapid prototype integration. We can help blur. Sometimes there's a blurry line that you may want to start with 3D prints. You may need 5, 10, 50, 100 to kind of, while you're, say, waiting for an injection mold tool, it's going to take 2.5, 3 weeks. We may produce you some 3D printed parts, and that can be a great way to kind of blur that line and keep you in parts the whole time, so your manufacturing facility is ready to go. Justin, do you want to speak to those next items? Little time checks, 11:37, so we need to progress.
Yep. We use a lot of our customers do ask what software we use for mold design, and what that software is Cimatron. We can read in files, step files, Parasolid. All of your major 3D files we can pretty much read in, so not an issue there. Moving on to the MUD or master unit die base to reduce the cost and time. So we have several different options for our customers. If a customer comes to us with an RFQ and they have a specific MUD size in mind, we can quote to that. That is not a problem. An actual MUD that's in the MUD standard book. Or we have several custom MUD sizes in-house that if a customer decides that they want only us to build a tool and run parts, that's a perfect scenario, because then we can pick a custom MUD size that will run and stay in our facility. That is going to be your most cost-effective tool to build with us. We also offer building independent tools that can ship out to your molder of choice as well. When you buy a tool from us, you own the tool. We don't lock you into a corner to where we say we own the tool, you don't own the customer always owns the tool. So on the front side of the RFQ, that is information we will talk about with you and get clear so that you get a good, clean quote initially.
Very, very key point there, Justin. Just the exportable tools and not locked in. Our facility's open. You can come see first shots, see the whole process through. We'll go through and show you pictures and so on. So it is available to you. It's not a mystery. It's an asset you own that we can help you, mold well or ship to a production molder if that's what you're looking to do.
Yep. And these last two bullets, kind of we've hit on it a little bit. The tooling in aluminum especially can reduce cycle time and maintain consistency. And this all kind of goes back to talking about, and a lot of questions we get from customers. Do you guys put water lines in tools? Absolutely. We put water lines in tools just as you would a steel production tool. We don't cut corners. And with saying that, with adding water lines and aluminum tooling, we have found where we can even your high cavitation tooling, 2, 4, and 8 cavity tooling that we do and we've done in the past, that we can reduce cycle time because of the thermal conductivity of aluminum. We can run a faster cycle time that you can actually run in a steel tool. And that's where with your higher cavitation, you'll reduce piece price, and that's where your NIBOR hard coat comes in play as well. So you got a lot of additional advantages with aluminum versus steel.
That's right. Question came in that we can kind of address here from attendee named Drew. Are there any part size limitations at molding for Phoenix? So that is a very good point. What are we talking about in general? And I would say and Justin, you can answer this. Our shot size limitation, we have up to 340 ton press, so we can shoot up to 500 to 550 gram shot size. On the small size, we're molding parts that are, Justin, what would you say in terms of grams on the small size?
You typically right around 1 gram is about as small as we can go, and then you really get into kind of your micro molding at that point.
That's right. Slightly different technology. So we're looking at kind of, volleyball size, we tend to say, or smaller. Now, how those dimensions vary depending on your X, Y, and Z, we may be able to get at 18 to 20 inch long part. If it's short, it kind of depends on that ratio that you have in the part. I'm holding up a larger part, for example, here that we molded. That's an armrest for a part. We have a large lacrosse basket, very complex with some features that it required high pressure to get the plastic to fill through those ribs on the side, for example. So we can make large parts and then down into smaller parts with good clarity. We've got an overmold here. I don't know how well you can see with the blurred background. My apologies there, but good capability for parts that are clear, parts that have complex overmold, which require a lot of shot pressure and a lot of care. So there's a good capability with part size through our facility. Hopefully that answered that question. So next, another poll that's coming up. Just a quick little time check. We've got about 17 minutes left. So have you used aluminum tooling limited to prototype and product development? So we got yes, no, and considering for upcoming project. So we want to address this question of, can aluminum do what I need? So can I take advantage of that fast lead time, that low tooling cost and good part cost with aluminum? And can it help carry me from early development up through production? So that's the intent of this question, so that we make sure that we're addressing your needs. Give that a few seconds.
Okay, right. And talking about what type of aluminum that we use here at Phoenix, and what we use is called Hokotol aluminum. It is we've used a lot of 70-75 in the past, but we have now moved everything over to Hokotol aluminum, and part of the benefit is with your lower grades of aluminum, the way that they're produced. On your thicker blocks, when they're rolled, the thicker blocks are like 70-75, the center of the block is softer. So when obviously most of your detail, when we're cutting our detail and you get into the center of the block is where the detail is going to be. Well, we don't want that to be soft there. And what we found with Hokotol, it maintains a hardness throughout the block that's consistent. And it helps not only for machining, durability, and it also is more consistent when polishing. And that's part of the reason for this picture here. This is an A1 finish that you're seeing that was used with Hokotol. If that was a lower grade aluminum, you would see pits and pitting in the aluminum, where you're not going to see that with Hokotol because of the hardness and the consistency when it's produced. And it also reduces machining time. It's not as gummy. It's much harder, and it's actually much easier to machine. So that's another benefit of using the Hokotol aluminum. Moving on to the next bullet point. I've talked about this a couple times now. The thermal conductivity with aluminum. It's just it gets rid of heat quicker, and it also heats up quicker as needed. So It's a huge benefit. Whereas in steel tools and thicker blocks, you'll have your hot and cold spots, which can lead to processing and part issues when you do have hot and cold spots. Where with aluminum, it's much more consistent throughout the block. So it's another advantage we have there. Also, with the cost effective for aluminum versus steel, and the machine time. Aluminum is much cheaper than steel, obviously, to purchase. And then the time savings of you're not waiting on hardening the steel, where aluminum, we can literally be cutting your detail from the time we get a PO. There's been times where literally, if we get a PO in the morning from a customer, we're cutting detail potentially that afternoon or the next day. So that is a huge advantage that we have with aluminum versus steel. I'm going to let Jesse talk about this a little bit, but just talking about the pictures to the right. One thing I do want to bring up is the top picture. You will see the darker gray center section is a hard coated cavity block. The outside is not hard coated. That just kind of shows the difference there. The second picture down, where you can see the diamond finish that they're polishing up. Just for clarity, when we say A1 finish, that is absolutely achievable, but when you do go to an A1 finish, you must hard coat the tool. Unhard coated, we can go up to an A2, A3 finish, but when you're trying to achieve the A1 finish, you do have to hard coat the tool, and that's something that we will state in a quote if it's requested during the time of RFQ.
That's great. Thanks, Justin. Some other points on that tool up in the upper right is that's a multi-cavity tool. So you see all those little kind of features that are sticking out from the core and cavity blocks are cavities. So that's a small part, multiple cavities. So we are very used to that. You see that that's a production grade type of tool. So we can address the needs that you have when using aluminum to make high cavitation tools that are capable of molding a lot of parts. Also, the bullets start to show, intricate and precise detailing. So we can get down to, very small ribs, fluid channels. I mentioned O-ring grooves, those sorts of features with high polish, excellent capability out of aluminum, runs extremely well. So you can really get the part design that you want. We've mentioned already the filled as well as the unfilled materials. So a lot of people think, oh, you can't run glass filled or talc filled or carbon filled if you get into carbon fiber through aluminum tools, and you certainly can. Very well uncoated for lower quantity, and then once we coat it, we can run higher quantities. And as Justin said, we've run tens of thousands of parts with filled material through aluminum. It's polishable, it's weldable, and we've talked through that a bit. And then it's very durable material on its own, but once we plate it, it's even better. And that allows us to take our tools from, we'll quote unplated at about a 5,000 shot mold life, and plated we can extend to 50 to 100,000, typically 50, depending on the part design. But that can be multiple cavities, as shown up in the upper right. Multiply that by 8, you can get several 100,000 shots out of a tool. And when we reach those numbers, that doesn't just mean your tool is going to spontaneously fail. It just might mean, kind of like a oil change or a car that starts to get slightly higher mileage, you just might need to do, we call it grooming, some tweaking to parting line, ejection. Sometimes the gating area might just start to develop some more extensive flash. We may go back and kind of retouch that. This plating can be milled through, so we can machine through it to create new features if you want changes, or if we're going to pocket it. It can also be stripped and then replated without affecting the base material. So it's something that we can do in really infinite times to help create a long lead time, or a long mold life on your tool. So we can get these tools to run, sometimes 250, 500,000 shots if necessary. So add a lot of value to your tool for not much cost. All right, next slide. We're nearing the end here. With time, we've got about 10 minutes left. So we wanted to address materials. This is an important part of, one of some of the early advantages that we talked about, being able to run parts in your correct materials. What this is a list of the materials that we carry in-house. We've got kind of the standard engineering grades such as ABS, nylons, polycarbonates, acrylic. We also have some of the flame-rated materials. We've got a DuraPet material that's a recycled content material so that we can help produce parts that are in more recycled material. We also have a lot of glass-filled materials, as I mentioned, so we've got a lot of capability there. Then very importantly, we can mold your materials. So if you have a high volume production supplier or a previously color compounded material that you want to provide to us to mold your parts, we're happy to take that and mold that with you. We just quote the parts without the material cost included. We can also find and attain, sometimes small, depending on what you're needing, sometimes larger quantities of material that's custom for a project. So you may not have it, but you need to spec it. We have very good distributors that we can get material in within a couple of days. Often, if you're talking a tool design and manufacturing done in 2 weeks, trying to get the material can easily outstrip that time. So we're on it early. We'll help you with the logistics. We'll help you get the material selected, either through a combination of our own materials that we might suggest to you if you're not sure, or help you find the material that you need quickly. All right. Then just some brief factors to consider. We're here to help you with speed. We're here to help you minimize cost and maximize quality. So on the cost side, aluminum saves costs on material and machine time. It's also highly modifiable and fast to machine for repairs. So that helps you achieve lower cost and also high quality, and get you what you want on your part design with as I mentioned, making features metal safe, possibly some modifications if need after molded, or they may run just excellently as they are and you're able to get right to it. So our goal is to help you reduce costs as much as possible. Then a lot of those things are also very tightly related to speed. We're interested in getting you tools. Justin mentioned sometimes we can start milling materials same day that you place the PO. We're interested in very quick turn. Our quotes are turned around in somewhere between same day to maybe 2 days if there's a little back and forth, but typically 24 hours. And then our quality, our focus on quality, as Justin said, we don't cut corners. We simply use the right material. We are involved with the customer early on to get you good DFM feedback. And then our expertise and our capabilities with things like 5-axis CNC and our expertise with the software for programming to really help achieve quality in that fast amount of time. And then our vast knowledge of the materials that we're working with aluminum, like exactly how to work it so that we get you the best quality. And then areas with tight tolerances that might need to be dialed in, we can help identify that with you early on so that we can achieve that exact fit that you need. Next slide. That is near the end here. We wanted to spend about the last 5 minutes are going through questions. I have a few sample parts that I can show that show things like clarity. We can do inserts, that sort of thing. So I'll show those. If you have any questions that we haven't addressed so far, please type it in the chat and then we can address them as we go. We'll give a few seconds there. All right. And then as you're considering questions that you have, I'll show you some of the samples that I wanted to address so that you can see some of the capabilities that we have. This part is a molded polypropylene part that's very complex geometry, has holes in the ends, which are kind of hard to see in a virtual meeting, but there's holes in the ends that require slides. So complex shape, difficult geometry, tricky material to mold, a 30% glass-filled polypropylene polyethylene combination. Then this part I showed briefly earlier in the presentation. I'll kind of step aside so you might be able to see it better. This is a housing that has a clear window with an elastomeric overmold. The two-shot is something we're very capable with and can help address. Sometimes you have engineers have questions on how do I engineer this part so that the overmold works well, it flows well, it sticks to the substrate material. This is something that we can help guide you through. And this part, it's going to be very hard to see, but we can mold in brass inserts. So when you're looking to assemble the part, front back housing, or this to a plastic part to a sheet metal part, you need brass inserts. We will mold those into the part as we're molding the component. Another kind of two-shot concept is dissimilar rigid materials. So this, we have a clear window and then a rigid red plastic overmold. So we can insert a component, whether it be dissimilar plastic or a electronic component, if you have a strain relief and so on. That is something that we can insert into the tool and then mold the substrate material around it, or the overmold material, excuse me. And that's an example of a very complex part that we did here, difficult geometry, tricky texture, larger part. So any of those kinds of secondary processes that we can do, complex molding. And we can go through the part design with you early on to answer questions that you have. So a question came in of how much of your production is done in the US versus overseas. The answer to that question is that a substantial amount, we build somewhere between 25 to 40 tools per month domestically, our capacity. And so we can mold a lot of parts, we create a lot of tools and then also mold a lot of parts. So a significant portion of our manufacturing is done domestically. A lot of the, say, larger parts are often done overseas. So beyond that 550 gram shot size that I mentioned, sometimes if a steel tool is required, we may do it overseas at our facility there. Sometimes there are some geometries that are better suited for our capabilities in those facilities. So it ends up being probably in the ballpark of 50-50 on the injection tooling and molding by numbers of tools that we create.
And all the tools that are produced or that built at Phoenix Proto are all designed, built, and molded at our facility here in Michigan. Those tools would not be sent overseas and ran or anything like that. They're all ran at our facility.
That's right. We also do a substantial amount of our tool building domestically is made for molders that are going to be high volume production molders. So we'll build tooling designed for export. So we build it, we mold it, we get it qualified. We may take it and have it hard coated and then export the tool. So we do both, really focus on fast turn on your parts. And then we can also do the model where we're going to be exporting the tooling if necessary. So huge, big capability, and we end up doing probably kind of 50-50. Now, something that's important is that you have the option. We can talk to you about those options, what the pros and cons are, why you might consider one versus the other. We can potentially quote it both ways so that you can help make a decision, because sometimes there's a lead time or cost factor that may weigh one versus the other, and we can help you walk through that. Our toolbox is such that we can just kind of make options available to you, educate you on the pros and cons, talk you through it, and then you make that decision, and we'll help then execute extremely efficiently either way. Okay, with that, I think we're near the end of the presentation, or at the near
we have
the presentation.
Hey, Jesse, we have one more question that did come in. Sure. How do we schedule a tour of the facility? If we go to the next slide, there's our contact information, and we can absolutely accommodate setting up any type of meeting, on-site visit, anything that to accommodate the customer.
That's right. As well as along the same lines is going to be just how do I facilitate quotes, and you can send them to Justin and myself. Again, I'm outside sales, so I can go meet with customers on site. I can come visit the facility and talk to you about your project, or we have local salespeople that can do that also around the country. So we can look at that. You can then send in files for quote and DFM, so we can go through that. And then if you want to come see the facility before you cut it loose, you contact Justin or me, and we can set up that tour and help you with the travel arrangements and so on. But being able to go domestically and go see the tool and see the facility and know where it's all made is a big advantage that might sway what Heather asked earlier about where you have this tooling built and how that works. So we can help show you how the logistics are going to work, the team that's going to be involved, and how it will run. So there's our contact information. We really appreciate everyone's time today. Thank you very much. This is an exciting technology that we're looking forward to working with you all on. If you have any questions, please get in touch. We're here to help.